Today we are talking about a question. The question is why soft iron is used in making electromagnet of electric bell but not the steel. Now I want to make you more clear. Look at this. In previous class I told you about this electric bell. This is electromagnet, U-shaped electromagnet used in electric bell. And the question is why it should be made up of soft iron, not the steel. This is the question. What happens when steel is used? If we use soft iron, then what happens? Now, I want to make you clear about this with some other diagram. Look at this diagram. Let's say this is a magnet. It has north pole and south pole at its two ends. Now, let's take some nib of pen, and attract it with one of the pole, say north pole. Now, how many nib can be attached one after another, making a chain? Make it. Try to hang more and more. Now on the other side, take paper clip and try to make a chain of paper clip at another pole, that is south pole. Let's say this is, let's say, paper clip. Now what is found, practically you will get some difference. What I am showing here, this is nib and this is paper clip. What I am showing, the number of paper clip are more and the chain is long. But on the other side, number of nib are less and chain is short. Intentionally I didn't make this diagram, but it happens experimentally. We can check it. Now I want to inform you that nibs are made up of steel and these paper clips are made up of soft iron. Now looking at this simple experiment, what can you declare? These pins are magnetized by this magnet, but the magnetism is weak. They are weakly magnetized because long chain is not made. Weakly magnetized. That's why we can say that it's still magnetized weakly. But on the other hand, look at this soft iron. There is long chain of soft iron. What it means? It means soft iron magnetized very strongly. Magnetic strength gained by the soft iron is greater than the magnetic strength gained by the steel. But one thing, if we separate this first paper clip from south pole, holding the first one, if we separate it, then what is seen? All of this this paper clip falls down. And if we separate this first nib from this magnet, then what we get? They are still attached with each other. The magnetism retained by this nib, but magnetism is not retained by the soft iron. This is the difference between steel and soft iron. That's why steel is sometimes called hard magnetic substance, and soft iron is called soft magnetic substance. What it mean? Soft magnetic substance and hard magnetic substance. The substance which retains the magnetism for long time, which retains the magnetism is called hard magnetic substance. But the magnetic substance which doesn't retain, which loses the magnetism at once, are called a soft magnetic substance. And this is the difference between soft iron and steel. That's why if we use steel here, then what happens? Once when we switch on the circuit, then the U-shaped magnet, electromagnet, gains magnetism, and it retains that magnetism even after the breaking of the circuit. When it magnetizes, it attracts soft iron bar, and this spring also moves forward, and there is break in the circuit. Even after that, it retains the magnetism and it keeps on attracting the soft iron bar. And if it keeps on attracting the soft iron bar, then what happens? Hammer once hit the gong and it remains attached with the gong, and the alternate this hammering of this gong cannot take place, and that's why it doesn't work. That's why we need that substance which quickly loses its magnetism within fraction of second, and that's why it is made up of soft iron. We are using a soft iron U-shaped bar, which when once magnetized by pushing this push switch, and it attracts the soft iron bar. In the meantime, this spring and screw disconnect, and within fraction of second it loses magnetism because it is soft iron, this soft magnetic substance, and that's why it loses magnetism and soft iron bar goes back. Again circuit becomes complete, and when circuit becomes complete, again it gains magnetism, and that's why within fraction of second there is complete circuit and incomplete circuit, and that's why hammer repeatedly hit the gong. So we are not using steel in making what? Electromagnet of electric bell. Or if it is used, the electric bell doesn't work. But we are using what? Soft iron. Steel is not used, soft iron is used, because within fraction of second it loses magnetism, and the alternate complete and incomplete circuit helps the electromagnet to work by hammering the gong repeatedly. Okay, this much for today.